today it's a very important day because this is a subject normally we don't touch upon. But luckily we got the good speakers, and apart from the speakers, there are two people have joined us now from the industry side. So it's good to see here. There are people in the validation and this thing, and consultant here. The end user client is here, and there is another gentleman from Tablets India is here, and Mr. Sasitharan, who is also facilitating all this clean room design, and he's a trainer for All India from ishrae. So I welcome you all for this wonderful session. So here, see, we don't want to be very formal questions, asking them and answering them. See, we wish you to come out and ask questions, because we were expecting you to write the question and give it to us, but very few people have given. See, now it is open for you to ask any questions. We will help you to answer. Any questions? Yes? Yeah? You can. Okay. You can ask directly if you want. There. Come.
Hello. Sir, the question to Sasitharan sir. Sir, what is the importance of anti-static gowning in a clean room, in some of the pharma clean room? Anti-static gowning.
Yeah, we discussed about temperature and humidity. Basically, it is called relative humidity, you know. In certain areas in pharmaceutical manufacturing, particularly where powder handling is there. Now, tablet manufacturing, you handle a lot of powder. And in liquid injection, that liquid injection and powder injection. So, similar such areas, there is low RH areas. RH, relative humidity, as low as 30%, 20% each. When relative humidity is very low, it creates an anti-static electricity on the body, you know. Like in summer, you might have noticed when you open the car door, suddenly a spark comes, you know. The static electricity from your body is passed on to the car. If it happens in a facility where you use a lot of solvents, it can ignite, it can spark as well as create fire hazard. So anti-static garments are garments with carbon thread running over, and there are cuffs which is connected to the earthing, you know. So every machine, including the clothes, as in that your shoe covers, everything is earthed to the ground. So there is no static build-up on the garments. So there is special garments or clothes available. Even the floors can be anti-static. Even the walls can be anti-static. So no static electricity get accumulated anywhere to create a spark and a possible fire hazard.
Thank you, sir. My next question is?
Just to add into, sir, sorry for that. Anti-static gowning, when we talk about, so that is very important in the pharmaceutical industry when you typically deal with the biosafety cabinets. So biosafety cabinets, wherein the process itself it's a hazard when you deal with the APIs, powders and all that. So that process has to be in a very controlled way, and that has to be taken in a very precise way. That is the reason that anti-static gowning plays a very crucial and important role. Correct, sir?
Can you just brief us, where can we use this anti-static gowning?
Pardon me?
Where can we use this?
It is in the clean rooms where you have a low relative humidity condition. Humidity, which is normally, the relative humidities are normally at 50% plus minus 10% RH. So in low humidity areas of 20%, 30%, you require anti-static garments. In microelectronics, where this anti-static electricity can be damaging to the chips or the microelectronics, which is very, very important. Microelectronics, it is compulsory. All the hoods, you can see the gown personnel connected by a wire to the ground, you know. So it's always to prevent static electricity buildup.
See, how do you connect this RH with the anti-static?
Because if the air contains 80% nitrogen, balance is the other gases. And the relative humidity is the amount of water vapor in the air, you know. So the more the air is saturated with water vapor, it is conductive. When it becomes dry, it is non-conductive. So the material gets, even if you rub your hands together, it can be static electricity form on your head in a, see, static electricity is a problem in northern India because there is it's a very dry heat. In Bombay, Calcutta, Chennai and all, it is wet heat. We don't have that problem in these areas.
So my next question is, see, in some of the pharma companies, they are using floor mopping. So due to the mopping area, is there relative humidity will increase inside the conditioned space?
First of all, is it permitted?
Yeah, yeah. In fact, in pharmaceutical facilities, we don't advise sweeping. Jhadu nahi marne ka. That is, sweeping is not allowed because you are allowing the settled particles to go up. So you should have the vacuum mopping or the wet mopping and then vacuuming it out. When you do wet mopping, of course, there is a thing called a residual contamination. If you are using for the wet mopping some disinfectant, that disinfectant solution itself can dry and create particles in the air. So it is for us to decide or validate which disinfectant is useful, which is not hazardous to your product, you know. So there is a department called validation of cleaning. The cleaning validation also, there are specific documents available for validating the cleaning process.
My question is whether due to this relative humidity will increase inside the room.
Yes, of course. When there is water vaporizing, naturally there will be increase, but your HVAC system design will take care of such transient humidity increases.
Okay.
It should not be a problem.
Okay, thank you.
And remember, this is being done at off hours, not during production, you know. So humidity increase is applicable only when you are doing some production activities.
Hi, it's a very good question. Actually, during cleaning, because of water, otherwise disinfectant, the RH will get to definitely increase. It is acceptable. For example, if any alarms will get generated, no, we can have the justification that due to this cleaning, that RH may go high. That is one thing. And we'll do the, okay. During that, we'll do the disinfectant validation. During the selection of the disinfectant also, we'll do the, what is the volatile, how much percentage is required with disinfectant and water, and what is the contact time required. That is one thing. After disinfectant, no, we'll remove that disinfectant with water of completion of that. Then we'll remove all the residues of the disinfectant. Okay, that is one thing. But during the cleaning of the area, we'll use a lint-free cloth. Okay, it will not shed any, for example, dripping of waters. It will not drip any water. That's why we'll maintain with saturated, not saturated, with optimum cleanliness. With water, we can clean the area, and after cleaning immediately we should not start the activity. We should wait, like based on validation, whether it requires, for example, 5 minutes, 10 minutes. After that only we should do the activities. Okay, thank you.
Thank you.
I think the whole idea of doing this process, basically inside the clean room, there you should not leave any residues. So when you do also the air visualization test as well, so there are various techniques are available. So earlier days people used to use a glycol base, means glycerin water based fogger, and that is something, it leaves the residues and it's very difficult to clean the things and get that classification back to the normal position. Of course, there is a chances of getting the RH increased, but you have to take care of that. At the same time, you have to maintain that the residues should not be present, which will disturb the classification. So you have to bridge both the ways.
Thank you.
Sir, you are into tablet manufacturing, right? Okay. Yeah. So, can you please introduce yourself a little more?
Okay. Actually, my name is Venkat Shivareddy.
Mic is not really okay. Sound is not okay.
Okay. Okay, my name is Venkat Shiva Reddy. Okay, I am working in Tablets India. Okay, I am working in Tablets India. Is having both injectables, OSD, all those things. That's why these disinfectants, cleaning validations are very important. Okay, why? Because nowadays, especially this TGA, means Australia, it is more focusing on the disinfectant validations. Previously, it is just, for example, previously we use IPA, otherwise Dettol, other Savlon like that. Now it is not like that. We should use the bactericidal and fungicidal and sporicidal like that of disinfectants, so that along with our AHU, all those things, whatever the, for example, floor contact, otherwise metal contact, otherwise surface contact, those should be removed with the help of these disinfectants. That's why those disinfectants also should be periodically changed. Periodically changed means once in a week we should use 1, 2, 3 like that. Okay. Anything?
Thank you. See,
Okay.
I have a question for you. Generally, tablet manufacturing facility, normally there is no clean room. They maintain a clean room. Then how do you control the airborne particles?
Okay, actually, this filling, actually I started with injectables. Injectables will require to grade A classification. It is under the laminar airflow, and surrounded, in case of isolator, we may go for surrounded by grade C. Otherwise, it is a, means ORAPs, CRAPs will go for the grade B classification. Okay, this is the, all your governing practices, everything will maintain. Okay, but whereas to means tablets, capsules, all those things now will maintain a grade D classification. Grade D means, and during production, and we'll wear all the governing, for example, garment, for head cap, and either shoe covers, booties, all those things will maintain. We'll maintain a positive. We'll maintain a pressure differential between the other rooms, and in tablets manufacturing, in operation there is no particle limit. Only a test only is applicable in OSD.
For a clean room.
No, it is a clean room only,
Clean room only.
but it's grade D.
Okay.
It's called grade D. It's ISO 8.
Okay.
It's ISO 8.
Okay. Okay. Thank you.
Thank you.
Right. Mr. Vishnu, I have a question for you. How can IoT, that is Internet of Things, devices be utilized to enhance the HVAC system performance in
The IoT, this is in specific connection with the clean room?
Yes.
Okay. In a clean room, IoT systems can actually give real-time monitoring, can give real-time data of the current situation of the clean room. If there is any, I mean, if all the parameters are in check, are in order as per the design, or is there any variation, immediately it can give, I mean, without any interlinking cabling or any sort of other mechanical or physical devices, it can connect immediately to the main center, the heart, the control unit, and give a direct feedback immediately. And as and when the performance data changes, it can raise an alarm. That's something which can be done. And the other advantage is that even if the particular system goes defective, you don't have to always necessarily enter the clean room and thereby disturb the operation of the clean room.
Okay.
So that is one big advantage. But at the same time, with the level of technology that exists with IoT, because IoT is comparatively a newer technological innovation, it is still not have become foolproof.
Okay.
Which means the reliability at the moment is not very high. IoT, while they provide a lot of convenience, a lot of safety factors for the operation, as far as the operation of the clean room itself is concerned, it cannot be 100% dependable. It has not reached 100% dependable mode of communication. So for anything which is very critical, I would rather not suggest IoT as the main means, but as a supportive means, yes, of course, yes.
Okay.
As a secondary system, yes.
Again, one more question to you. See, today everywhere people are talking about AI. Even last, when we had another conference, one gentleman was talking about this AI, even it is used in the pharma industry. So what is your experience about it?
AI, my experience, strictly speaking, my experience is not much in AI, but definitely AI has been widely used abroad, not in India, again for trend analytics or analytics of the history. If you know a set of value over a period of considerably a longer period of time, and compared to that, automatically the trend analysis becomes much faster, and the system can predict. It is also called a totally new field of investigation is coming up. Or is developing as we speak. It's called predictive analytics. So in predictive analytics, what they do is they take the data, the performance data, which is collected over a period of time, based on which and compare it with the current operational parameters, and based on which the AI can predict whether the system is running rightly or the system is going to end up with any deviation or even major malfunctions, and can prevent even prevent such malfunctions even before it happens.
Okay, thank you.
Thank you.
Now, Mr. Gaurav. See, what are the advanced validation techniques are used to certify clean rooms to ISO 14644 standards?
Static.
Pardon?
Sorry, what?
Can I repeat the question?
Yeah.
What advanced validation techniques are used to certify clean rooms to ISO 14644 standards?
I think whatever the standards which we are talking about, so when we talk about the particle concentration and then the classification which we are talking about, that is ISO 14644 part 1, and most of the tests which we already covered. But the basic, to start with the basic test, air velocity, air volume, particle count, and along with the particle count, we have a recovery test, compressed air validation test. There are many things we can do it with the things. I don't think so anything apart from the standard there is advanced, called as advanced. Is that right, sir? Because nobody will go for the advanced unless and until standard will tell you.
I will add on to this. You have heard a lot about AI, artificial intelligence, correct? To me, I'm an electrical engineer. It's a highly hyped, this one. ChatGPT, yes, by AI, you ask a question, you get answers. But we used to get it from Google also, you know. Now AI is it has become a terminology used or misused or abused everywhere. 42 years back, I was taught in the second year or third year engineering about something called a staircase lighting, you know. In the staircase, on the entry of staircase, there is a switch. On the top also there is one switch. Suppose you're coming down the staircase, you put it on, light comes on. You come down, put this switch, light goes off. Same way you go up, you know. Today, AI or IoT, Internet of Things, you know, what do? They have a sensor, motion sensor. When you come, light comes on. When you go, light goes off. So that becomes AI or IoT, etc., by big names, and the cost increases. I can do it with a single toggle switch, 2 switches on 2 sides, and wire it permanently. So it's, you can't negate technology. You can't say yes or no. Now like particle counting, etc., what he has been doing it for 35 years, you know. I don't think there is any much change in particle counting method per se, or velocity measurement per se. Maybe you may use, instead of a tungsten wire, you may use a uranium wire or something. Otherwise, there's nothing called an advanced technology in clean room monitoring as I had seen.
Only thing is, you know, the instrumentation side, there are specification changes. ranges changes, resolution changes, and that is again as per the standards and guidelines. So the whole idea of, for the classification or the monitoring, we have to comply with the standards and guidelines, and the equipment should be calibrated, and those should be meeting customers' SOP and meeting the standards. That's the only motto of doing this exercise.
See, as we know the importance of the clean room design, see, we normally taking uppermost care because it is again life-giving system. So that is where, even I can show you some of the video. Can you please play that PPT? See, we are just taking things casually. The bachelor happened, this contamination happened in 2007 and 8. Again, the FDA has issued the letter to close down the factory because of this contamination due to air conditioning. See, next. Yeah, this is another company temporarily shut down because of this HVAC system failure. You just see this also one of the company, inadequate HVAC system. They shut down the company for momentary, and whatever the medicine already they sold, they recalled all the medicines. You see this also. So what I'm trying to say, there are history says such a good major companies, corporate companies, was given a notice to rectify all this HVAC system. Because of this, you see this particular company, because of this wrong HVAC system, poor HVAC system, almost 60 people were died because of their medicine. Just imagine the seriousness of this. That is why when we design this HVAC, the clean room, you can't just take a chance. If you don't know, please take a support from the experts. That will help you to design properly, because it's again life-saving design whatever you do. We can't just take granted where the medicine where we take in or how important it is. See, there is a history. These are all I've not just collected. It's not, though the brands are very popular, but this is what happening. Only because of the HVAC system, many death rates also, that is only because of the HVAC system. That is why we will have to focus more on this. You see, all these companies. This is not I cooked. This is the information is available in net. Okay, these are the companies. Okay. Now move on to the
Just to add, sir, the list which you have given, in fact, if you go to the US FDA website, there is a complete list wherein US FDA issued 483 for the non-compliance related to the HVAC, environmental monitoring, non-compliance with the standard operating procedure on that. There's a complete list. And you will be surprised, there are the non-compliance of 483 as given to some Indian companies in the name of companies and in the name of owner also. Yeah. Some of the owners, they have got 483. So there is a complete list. So be aware about that. So whenever you buy any injection or the vaccine, just cross-check the list, which instrument you are buying. Sorry, which.
But there is a caution, 483 is like an FIR filed in Indian police station. Okay. FIR is a first information report. 483 is a form in which an FDA inspector gives a report after inspection. So there will be 100 points there, like the inspector might have seen somebody urinating on the periphery, etc. He will write. That necessarily need not be contradictory to the product quality, But 483 citations, when you read, be careful, understand. It's an accusation or rather some indiscrepancy found by the FDA inspector. A company is supposed to answer within a particular period of time, 15 days, rectify and submit a report, and it's gone. So all 480s are not bad. It is good. He is pointing out, okay, there is something going wrong, you correct it. I think you should be able to explain little more because he is from the industry. He had run the pharmaceutical companies,
Thank you, sir. See, it is a fact that, the inspections are going to be more and more in the industry, the pharmaceutical industry, and then apart from the US inspections, US FDA inspections. A lot of other inspections are also happening. Indian FDAs are also very active. So, thing is, it is too challenging for the small, medium enterprises in India to comply with every standard, right? The compliance cost is very high, and the small, medium companies cannot afford to have that. So, yes, they come, they are very critical. It is their job. The auditors, they come with a very critical mind. They identify the flaws in your system, and then they point it out, and then they give you time to rectify. Once you rectify, you restart you submit it, and then it is getting approved. So this is the normal system. Globally, it is going on. So there is nothing wrong in, somebody telling you that, yes, your system is faulty or something like that. So it is an opportunity for the companies to understand the implications and then try to correct it and then, rectify and then, resubmit the application to regularize the licensing. That is what happening.
Slightly,
Yes.
I differ from here. Whether it's a small company or big company, whatever they produced, whatever the medicine they produce is for the human, for the life. They can't compromise because I'm a small company. Am I right?
Yeah. Yeah, I agree with you. We are not talking about the compromise of the quality. Okay. See, this is a real challenge being faced by, in fact, I represent small, medium enterprises, especially the pharmaceutical sector. It is so difficult for small, medium enterprises today to sustain in the current regulatory environment, which is becoming a monstrous-like thing. It is so high. So, thing is, we get very little support from the government, from the agencies. So we are in crossroads. We should tell you that the small, medium enterprises in India, especially pharmaceutical industry, which is giving tremendous contribution to the exchequer. We have tremendous exports, and we are very much willing to produce the very high quality materials. We don't compromise that. But we face a lot of problems. We face a lot of constraints. Being small, our resources are limited. Especially if you look at it, initial capital costs are very high for a pharmaceutical industry. Even for a small industry, we need to spend a very high amount of capital investments now. And especially HVAC system. I know that apart from the regular process equipments, cost and all that, HVAC system occupies a very major cost. So this is a real challenge for the industry. And then not only the cost of the HVAC complete system installation, and subsequently we need to maintain to the efficiency, right? We need to, in terms of, the efficiency of the system, and also the power, the cost of the power. The energy cost is also very heavy towards the HVAC system. So, unfortunately, the resources are limited. The in-house resources are very limited for small-scale industries. So, we depend on external consultants. They are also very expensive. Suppose we need to outsource the maintenance. It is very expensive. We need to, calibration is expensive. Validation is expensive. So we face all these hurdles to run the SME sector in India. And then what we need is, we need ishrae type of organizations, especially with respect to the HVAC system, where they are experts. And we need to have a very high level of education and to train the existing manpower of the industry. This is what, even we are from IDMA, Indian Drug Manufacturers Association, and we have a very large amount of SME sector as members in IDMA. So what we do is we resort to education, educating the people, the resource available in the industry, so that these large industries, they have lots of resources, they can manage, no issues. But I'm talking about the small industries where we are really gearing up to adapt to this particular situation, and we are trying to do that. So we need a lot of collaborative work with ishrae and organizations for a lot of educational programs. We need a lot of help from consultants. We need all that. So if you do that, then we will definitely look up, and then we continue to offer very high quality products to the patients.
Yes.
With due respect, sir, I got my take on subject. All of you are using mobile phones. Which mobile phones you are using? I am using a Samsung. How many models are there? Samsung, how many? 1, 2, 3, 4, 10? Not more. 15. How many models or other makes are available? Because this model, whether I bought a 11,000 rupees one or a 1 lakh one, I expect it to be reliable. It should work when I want. Suppose everybody comes into like MSME, everybody wants to manufacture mobile phones which may or may not work. Dr. Ferno asked a fundamental question. Can quality be depending on small, medium or big scale? No. Because if I am in the operating table and somebody comes and tells me, okay, I got a so-and-so injection costing 10 rupees from MSME or 100 rupees from a multinationals, my wife definitely will go beg and borrow and buy from that multinationals, if the quality is deemed to be good. So to answer your question, Dr. Ferno, I think quality cannot be compromised because you are an MSME. Quality cannot be compromised because you don't have money. If you don't have money, don't come into this business. That's it.
No, I really share one of our experience. We have done 2 projects adjacent to each factory, clean room both, and they are making a saline. One is American company, the other one is Indian company. Both are making the same product. Here, exactly where the saline is being filled into the bottle, the small area, the class is maintained 100. Then it goes on 10,000, 1 lakh, all that. But whereas the other company, they do not have any system like this. The American company also selling 12 rupees per bottle, and the guy who makes without all these standards also selling 12 rupees per bottle. What do we say? But we can't say that they don't make money. They, of course, by doing all this facility, they sell at 12 rupees. Nothing is there, but they are also selling 12 rupees. Then where the margin goes? They are also Indian company, small company, but they make the same thing. So this cannot be compromised. This cannot even, they say, FDA on the pathkla.
But Dr. Ferno, again, the problem is that if you all recollect, 10, 15 years back, when Government of India gave special status to place like Baddi, Dehradun, Simla, etc., for setting up new facilities, even big Indian companies, I will not name them, big, not multinationals, they set up facilities in Baddi, Dehradun, etc., for Indian market. Okay. The companies based in Ahmedabad or in Bangalore setting up somewhere in Dehradun or Haridwar for Indian market. The facility what they are using it for USFDA approval. No, it is double standard. That means same product you may be knowing. So that means that a paracetamol made in the Indian company's Ahmedabad factory for United States, the so-called Goras, is better quality than what is made in Dehradun. It is a fact actually. The 2 qualities are there, and like Dr. Ferno's question, I answer unequivocally that quality cannot be double standards. I will not accept it if I am sick. Neither will you accept it if your parents or your wife or children are sick. So it should not be. But that is ideal situation, and we are not living in an ideal world. I think I should give him a chance to defend Dr. Furno.
Okay, Mr. Ila.
No, I think I want to give a very right message. Small, medium enterprises, the product from that doesn't mean that, we are of inferior quality. We also give, very, very high quality product, and we are exporting to 150 countries. Okay. So our quality is tested. What we are trying to communicate to the audience is, we need the policy makers to recognize the importance of SMEs in India, which is the largest industry base, right, for any sector. So we need a support system. We need a right ecosystem in place. That's what we are trying to ask. Okay. Otherwise, we don't, we believe in, we focus on quality. Whether it is affordable, not affordable, we are the largest customers for all these HVAC systems in India. Every small company, we have HVAC systems in large numbers. So we are giving a lot of business to the HVAC people system. So then these large companies, which are very few, small industries are small, medium enterprises are very large in numbers. So because of that, we are large customers for all these systems, HVAC system companies. So what we need is, we need a collaborative, that's what I'm trying to say is, we need a very collaborative approach between, agencies which are experts like ishrae and other people, so that, we do more and more education, awareness in quality standards, and then, work together for the betterment of the country. That's what I want to do. Ian.
Any question from the group? Yeah.
Good evening.
One minute.
Good evening, sir. My question to Mr. Sashi, sir. Actually, there are two great HEPA filters are available in the market. One is H13, H13 HEPA filters, terminal HEPA filters. H13 and H14 is available in the market. Great, two grades. Which filter is best? What is the difference between that? What is the difference between H13 and H14, and which one is the best one?
Yeah, I think he will answer it. H13, 14, 15, 16. 13 is definitely inferior to 14. 15 is better than 14. You see the percentage of efficiency rating, like G1 to G14 is the filters in the level of pre-filters, what we call. So G1, G2, G3, G4 in the order of accession, the efficiency is better. So H14 is better than H13. Difference is the media used. The media got a different criteria for the particles by which the medias are made, and it's a construction material difference.
Dhanashekhar, you have a question or answer?
I think he will answer the...
I have both.
Both, okay. First question?
First is the answer.
First the answer. Keep the mic closer.
See, basically H13 is gone away from the system.
Keep the mic close.
Now it is not being recommended by anybody. It is only H14. So H13 is basically 99.995 and H14 is basically 99.997. Anything above H14, it is U15, U16, U17, that is ULPA filters, right? That is predominantly used in semiconductor and solar cell line manufacturers, right? So HEPA closes with H14, particularly now with respect to terminal HEPA. Terminal HEPA, the recommendation is very, very clear with respect to H14. And if the HEPA filter is going to go into AHU, then it is H13. So you will have a primary H13 HEPA filter going into AHU, and in the terminal you will have the H14.
A lot of consultants recommending for the FE9 filters for the AHU side. 60% efficiency semi-HEPA. Then why are you recommending H13 and H14?
No, basically what is happening is to increase the life of the HEPA filter in the terminal, they are trying to do lot of filtration at the AHU level itself.
I agree with you, sir.
That is why they want to contain maximum contamination at the AHU level itself to make sure that the life of HEPA filter at the terminal level is increased because this is so expensive.
So then what is the lifetime of the HEPA filter, sir?
So HEPA filter, if the pre-fine and the semi-HEPA is there in the AHU,
correct,
the life expectancy of the HEPA filter is anywhere between 3 to 5 years.
10 years back, one factory we have installed HEPA filters. 10 years back, H13 filters. Now what? Now also same filter people are using in the factory, same. Because they are doing 6 months once they
But
do.
that's actually a problem.
So
that is actually
no, 1 second, sir. I'll complete my question, sir. So every 6 months they are making audit. Every audit is passing now. So they are not changing the filter also.
No, it calls for understanding of the audit. That is where my question comes.
This is a fight between the manufacturer and the user.
No, Ferno sir, that is where my question comes to the person who is sitting in the center. Sorry, I am forgetting your name. Sir, there are two terminologies that is used in the pharma. Particularly the company which is manufacturing multiple products. So one is SBP. SBP means shift change, batch change, product change. Right?
Correct.
Can you keep the mic closer?
You're right, sir.
So SBP, that is shift change, batch change, product change. Because clean room is common. It is a commonly built. But then there is another terminology called ITV. It is called inspection, testing and validation. Now my question to the person who is sitting in the center, with respect to shift change, batch change and product change, what is the recommendation for ITV? Because this is where so much goof.
Oh, only now you are coming to the question. Okay, thank you. Hello, your answer.
See, ideally speaking, when we talk about any validation basically, so as I said, there are 3 states. So as built, okay, at rest and in operation condition. So whenever you have these 3 states to be monitored, then you need to do validation for all the 3 states. Another things, when it is the facility is completely ready, that time generally, it is recommended by the SOP of that particular plant that between the 2 batches, you have to ensure that what are the environmental parameters or the related to the classification, you are maintaining those area or not. That you need to, by default, and that is where most of the pharmaceutical companies nowadays, they have started their in-house validation facility also. Because rather than depending upon the frequency of the twice in a year, basically they do the in-house validation regularly if there is a change in their facility. Sometimes there is a problem with their HU, there is a problem with their pressure maintenance, there is a problem with the required flow rate, there is a problem with the number of air changes. So that has to be monitored before the batch and after the batch, and that is where something has to be defined in their SOP. It is highly recommended.
Sir, then what is the air changes for the class D and class B, class A?
Generally in the area it is more than 20, but
it is not in the protocol. Actually 30 to 40 is for the grade D, but they are telling 30. So
see everybody is talking about the grade A and B, so which is more than 20. But of course, means in D, C and D probably 30, 40 can be. That is something which is we talk about in the non-classified area.
I think I'll clarify you. Okay.
Yes, sir.
I think there is a debate between you, he and all, Okay. See now, any room which has to be classified for any class, ISO 1 or 9, in between, you have to decide what are the activities going to be conducted there, what is the type of generation of particles expected from the activity, because it depends if it's a tablet area or ointment area or injectable, powder injection, lyophilized products or anything, the particle count variations are so many. Unless you estimate those, and now he asked a question about S13, there is a counter that S13 is not valid and is not used. What you meant is S13 is not currently being promoted, not used, promoted. S13 exists, it is still valid, okay. Now, if I want to design a ISO 8 facility, I may as well decide with the S13 filter. What's the problem? So, no filters are invalid.
You're right,
okay.
you're right.
Now, your question about life. Life of the final filter depends on what's the particle coming behind that.
Correct.
So, if you have a good pre-filtration system in the HU, you maintain it properly, you change those properly, you can have I have seen facilities, liquid injection facilities working with HEPA filters which is 15-year-old. And remember, as the filter gets loaded, the efficiency increases. If the filter don't have leaks, if the efficiency of the filter, if it's 99.9% new, after 3 years, efficiency increases because the filter is more efficient. Okay. So there is absolutely no problem in using an old filter, provided the pressure drop is taken care by the AHU and also the filter doesn't have leak. For a single product facility where there is no particle generation like in a liquid injection plant, filter can, I had seen it working for more than 15 years, no problem.
Thank you so much, sir.
See, there are some questions has come up in, I think, YouTube. So we have taken the question just on behalf of you. It is I think, shoot out by you only. I'll ask the question on behalf of you. See, there are, how frequently should we change the HEPA filter in injectable plants or OSD plant? It is simple as simple as this. Depends on the choke. I mean, if the filter chokes in a week, you'll have to change it. In a month, you'll have to change it. Or in 6 months, you'll have to change it.
See, by general criteria of a thumb rule is that when the velocity falls less than half of the rated velocity, or when the pressure drop increases double that of the initial pressure drop. That's a thumb rule. But again, if the velocity falls much below, you will lose the pressurization grades, so you will have to change it. So it's a guy who validates the facility has to decide, our engineering team.
This question to Mr. Vishnu, does liquid oral medicine manufacturing facilities require HEPA filters? Does liquid oral medicine manufacturing facility requires HEPA filter?
Yes.
Yes. If yes, whether it is on the plenum or in the terminal?
Again, that depends on the quality requirement, the air quality requirement. I would suggest if it could be given at the terminal, it would be more efficient. But at the same time, as right now the two gentlemen had the discussion, it is better to go with one set in the air handling unit so that the ultimate particle load on the terminal filter is reduced.
Okay. Thank you. The same, again, one more question for you. Since you spoke a lot about energy, you gave a lot of options to save energy in various options. Is there any correlation between air changes per hour and energy efficiency?
Definitely yes, definitely. The larger the number of air change, the fans will have to work. If it is passing through a cooling coil, then cooling coil will have to work. The corresponding chiller will have to work. So depends on the type of process. If it is purely a ventilation requirement, then definitely the fan power will definitely go up. Then the corresponding load on the filters also will be high because it's handling, or it is made to handle a huge amount of air. And if it is cooled, if that much air is cooled, definitely the cooling load also will go up. So definitely there's a huge correlation between the number of air changes and the power consumption.
Thank you. I think your question is answered. Then now, Mr. Gaurav, can AHU be turned off in non-production hours? Based on your experience, what are the complications faced while restarting the AHU for distribution system?
Of course, it is not recommended because when you are putting the AHU off, that means you are creating a lot of condensation inside the room, inside the clean room, and that can damage the instrumentation inside. There could be a chances of increasing the RH value, and then there could be a chances of the disturbance in the classification of the room. So it is not recommended.
No, I have a question to the consultant, sir, connecting to the question.
Okay.
To the consultant, sir, connected to the same question. So basically, when you actually design a clean room, there are three conditions.
Tell me once again.
When you design a clean room, there are three conditions that needs to be taken into consideration. That is typically not given by the customer. One is the full load condition, second is the partial operating condition, and third is a no load condition. So, as he rightly said, you are not supposed to switch off the AHU, which means the clean room is not functioning, allowing the contamination and other things to come up. So, what is the consideration that during the design itself that we need to take care so that in all these three conditions are taken care? Even if I specify it very correctly, if a clean room has say 100 terminal HEPA filters with 100 dampers, how will you manually go and switch off, close those many dampers if it is in a partial load?
I think you misunderstood what has been told here. At trust, in operation conditions are not by switching off or on dampers or airflows. Okay. Now, when a system is validated for a particular airflow and airflow pattern, you are not supposed to work it at half speed, like what you told. There is some concept, I had read somewhere that some people do that, In the night you run it at half the speed. But when you do that, remember, suppose you got one IHU connected to 5 rooms with different pressure gradients, that pressure is going to change. Your fresh air quantity is not going to be proportionately reduced. So also the leakage. So your pressures are going to perhaps be in the opposite direction. It is contraindicatory. If you want, you put off the AC system, chilled water systems, that is a power consuming one, keep the blower on. And second point is that when a system, you have 2-year-old HEPA filter, everything is working, and suddenly you put it off for 3-4 days, there is something called agglomeration happening on the filter media. The filter can get choked. When the airflow is stopped, it will form a fine layer, and you will find the pressure drop increases suddenly. So it is not advisable.
Yes, sir. My question was something very different to him actually. If the clean room area is only 50% is used, there is no point in having all the terminals throwing the air and consuming the energy. So there the automation is there where you switch off you close the dampers and allow only the operational area to throw the air, whereby cleanliness is maintained in that particular area, thereby saving huge energy. So why somebody should not consider this as an option while designing itself?
Chandrasekhar, shall we continue this maybe after the meeting? Because see, I'm not getting any questions from you. See, whole day we were listening to this. Don't you get one question from your side? Or we are all masters of clean room? Come on. Any questions? Because we have only 3 more minutes. Okay, so I have a question for you. See, in your experience, you are interacting with the HVAC engineers, being a producer, end user, manufacturer. So what is your experience when you interact with the HVAC guy with respect to the clean room? What is your experience? What do you expect from us?
Actually, AHU as a vendor and customer now, that AHU should be designed in some cushion way. For example, I required 10,000 CFM, okay? That many AHU vendors, they're giving exact 10,000 CFM. But after 1 year, 2 years, because of the filters choking, all those things now, we are getting a differential pressure problems, DP problems. Means.
So what you are trying to say that whatever the capacity they are giving in the initial, that doesn't, maybe after a year or so, the capacity goes down. Yes. Instead, you wanted us to keep some cushion when you design. Yes. So that is your expectation. Yes. Other than this, is there any complications or difficulties to communicate to HVAC engineers?
And that is one thing. And we are cleaning all the filters. Okay, even for example, pre-filters, return air filters, fine filters. Whenever we are choking in the HEPA filters, we are replacing. But to duct cleaning, whatever the duct is going and here and there through the entire site, that it is very not reachable. How to clean ducts? Nowadays, auditors are more focusing on the duct cleaning, especially that FBD equipments, wherever the powder processing is happening now. They are very keen on the ducts. It may be supply, it may be return. They are more focusing on the cleanability of the ducts. Okay?
Yeah, yes.
Actually, this has to be taken care how to clean the ducts. Otherwise, is there any provision to clean the ducts? All those things to be considered in the design Otherwise, if it is a existing plant, how to do the duct cleaning to be initiated.
Sir, during the Vishnu's presentation, we have seen one slide showing the fabric duct. So I have a question to Vishnu and maybe answer for you also. See, when you run a conditioned air, okay, so suppose if RH value goes little higher, maybe without noticing it, the fabric sometimes gets wet, right? So if that, no, how? Because of the inner coating.
No, there is no inner coating for fabric duct. The fabric duct actually, there is no inner coating for fabric ducts. Fabric ducts by nature, particularly for pharma applications, are made with a non-condensing type. I mean, made into a non-condensing, with a non-condensing type of fabric, which is a self-breathing fabric. So what happens is, first of all, why do we have condensation? Condensation is mainly because of the existence of a very high delta, a difference between the cold and warm surface that is being created. That is why the condensation happens in the first place. But in this case, a very minimal amount of cold air, there is a layer created outside the duct, which is almost very close to the inside air temperature, inside the duct temperature. So that is why there is no condensation anywhere happening on a fabric duct.
See, generally in a clean room, we always go with a smooth surface, coving, all that to not to accommodate the dust or whatever, or not a microbial growth or something. The fabric, when you say fabric, it's made of tissues, right? Multiple tissues, like weaving.
Fibers, yeah.
Fibers, right? So every fiber has got some joints or connections or something, right? There is a possibility of maybe the growth of some microorganism or something like that. So how do we ensure that fabric duct is, because I don't know how to justify this.
First of all, for any microorganism like algae or mold or any such thing, fungi or anything, to grow them, you need to have moisture accumulation. Without moisture, in the absence of moisture, these things don't grow. Whereas fabric ducts, by nature, those fabric ducts used in pharma application don't allow that, number one. Yeah. Number two, even in the worst case, if those things mainly not algae and fungi, but dust from the atmosphere, if that gets settled on a conventional duct, there is absolutely no way you can clean it. You cannot go and clean a conventional duct unless you use a robotic duct. And with the insulation and all that over the surface, there is a huge potential that will be shedding. Those insulation particles, however good we clad them, even then there's a high probability that those will shed. But fabric duct, because it does not have any sort of insulation, it does not shed, number one. In the worst case, where it accumulates dust from the outside, you can definitely remove it, put it in your normal washing machine, clean it and put it back. So that is the most easiest way of, how you can keep a clean room clean.
Okay, I think it gives an answer to you also for the cleaning system. Yeah, any points please?
Yes, I think you have asked for the expectations. So probably I would say we have two expectations from you. One is, I think ishrae has taken a lot of efforts to increase your knowledge. So they are conducting ICP programs, then HVAC programs, wherein Shashidharan sir, San sir, there are many people, Gautam Baliga sir, they take a lot of efforts to share their knowledge, expertise, because they have been in this industry more than our age, right? So please understand, they are willing to teach you, so that, maximum times you have to, be a part of these things. And in fact, we as a Technovalley, we are the official partner for them for the instrumentation side. So whenever you attend those kind of trainings, ICP programs, you have a complete hands-on on the training. So increase your knowledge and, be a master in this particular industry, because there are many people in this industry who can really teach you and share the knowledge. Second thing, the problem, I'll take 1 minute. Second thing is, we also face one common problem, because when we supply the instrument, in fact, please understand, you are catering to the life-saving industry. So when someone take our instrument to the pharmaceutical industry for the validation and that calibration expires, most of the customers or most of you people ask for a, sir, my instrument is lying at XYZ pharmaceutical company, is due for the calibration. Can you send me the calibration certificate? Sir, how can you expect to do that kind of manipulation when you are doing the work for the life-saving industry? So stop that, and then improve your that attitude, because you are something doing and encouraging the manipulation. You are playing with someone's life. So stop that practice. Get the genuine calibration, send the instrument calibration, be a part of the calibration of the instrument, and ensure that your instrument is performing very well and within the standards, limits, everything. So that's my humble request from our side.
Thank you.
I will have a parting shot. The ducting, I think I should comment on it, because
You're talking about the fabric duct.
no, I'm talking about the duct system. Duct system, predominantly the rigid ducting with insulation as appropriate is what is preferred. And there is equipment available to clean the duct inside. There's a robotic, something like a rat, which goes into a hole and then goes there and then eats the vacuum, connected to a vacuum pump. But with clean rooms, there are a lot of drops, lot of filtrate, lot of dampers, etc. Practically, you cannot clean a contaminated duct, one. Second, fabric ducts are, I had seen fabric ducts using extensively for warehouses, where huge volumes of air has to be transported from one end to the other. Warehouses, then general purpose one. I have not come across a fabric duct installation in clean rooms. Yeah. Clean rooms, because clean rooms is a pressurized system. You got around 150 millimeter of water gauge pressure on the system because of HEPA and the different filters. So personally, if you ask me, I don't know whether it is going to leak or condensation, like Dr. Ferno asked. Yes, if a rigid duct with 2-inch or 1-inch insulation can have condensation, why not a fabric duct, which is maximum 1 mm or 2 mm thick. So these are all questions which can be answered, perhaps on a better day, on a subject which is closely related to duct distribution, air distribution, because this session has been a very generalized session covering almost all aspects of HVAC and pharma relation, pharma connection. So to that note, I leave it to it. I thank the organizers for bringing all of us together. And to me, it was a good session, good audience. A session is, I believe that a story is important, and the storyteller also is important, but the listeners are more important to me, If I tell a good story and nobody is going to clap or nobody is going to cry, what's the point in telling the stories, So thank you very much for a good audience, and I was impressed by the numbers, as well as you guys at 5:30 in the evening on a Saturday, sitting here, like donkeys, instead of going around, only few people left, The smart guys left, and the we people who want to learn has been retained here. Thank you very much, all of you, and I give it to you.
Last question, because he has been asking for a longer time. So, the time is over. I'm requesting all of you to bear with us. Last question.
Sorry, sir. First of all. Sir, generally in
Mic on.
Hello. Sorry, sir. Generally in classroom, HEPA filter will put 0.3 micron. When we decided for the clean room, why we take some 0.5 micron, 5 micron for design for class 1, class 8, something. We are using filter for 0.3 micron. When we want to take the clean room count only 0.5 micron, 5 micron.
Yeah, I think that's a good question, because why the 0.5 micron?
0.5 and
Correct.
5 micron.
5 micron. Why the count?
That will be designed for class 1 or a class.
I'll tell you why. Because see, the optical particle counters, 40 years back, were using visible light as a light source. That there is a something called a dark photometer on which there is a visible light source which intersects the particles coming in by a vacuum suction. And the wavelength of those reflected or refracted light is what is the limitation. The wavelength of light that time was 0.5 was the lowest particle which can be detected by visible light. Then now as the technology went up, instead of visible incandescent bulb, they are using laser, which is having a different wavelength, you know. So we could detect lesser particles. But still 0.3 micron is considered as, or 0.16 micron, you know, like the lesser light, 0.16 micron. But like somebody explained during the one, if you have a particle counter rated for 0.16, 0.3, 0.5, it is better. 0.16, it will have only 50% efficiency or accuracy or whatever efficacy. In the middle section, it will be having not 100%, but around better efficiency. I leave the percentage to experts like them, you know. I got my own skepticism when I see about these particle counters. It's like a person, your own eye, you know. I got a better eyesight than Dr. Ferno or anybody else. So like that. So 0.5 micron is significant because that was a significant particle size which could be seen by a visible light single photometer, discrete photometer. You want to add?
I just want to add in this. Basically, if you refer the ISO 14644, probably you must have seen that the particle size ranges are starting not from 0.3, it is from 0.1 also. So, but even when we are talking typically about the clean room application area, the 0.3, HEPA is rated for 0.3 for 99.97%. So when you go back to the penetration level also, it will show, ideally speaking, it should be 0.03 is allowable, but standard is not talking about. They are talking about 0.01%. That means ideally there should not be any leak. So that means the HEPA is rated for 0.3, so 0.3 and above, the next channel size is 0.5. So typically speaking, when we talk about the 0.5 and 5 micron, those are the channel sizes are incorporated not only from the classification point of view, from the certification, from the monitoring point of view. So that is one of the reasons. And if you want to really get into the ISO for the semiconductor industry, wherein the 0.1 micron also can be measured, wherein ULPA filters are involved. So those particle counters are also available.
Thank you. Right. See, further, if you have any discussions or any questions, he's here. Maybe you can spend some time with him. Because we have the very rich, experienced people are here, end users are here, consultants are here. You can interact with them even after this meeting.
Better that you write to the organizers and they will forward the questions to us.
We will respond to you. Finally, before closing this, the pollution control board across India is directly taking the readings from the factory, and if there is any reading goes beyond, so suddenly they send a mail asking them to control, or they visit, give them the warning. This is what is happening today, right? It is industry. Just imagine our industry, pharmaceutical industry. These are life-saving medicines they produce. Why can't we have this same system where some control device where they monitor this? Because this FDA, all paying the bribe and running this facility without facilities. So, as an ishrae, we have to really initiate to this kind of industry, pharmaceutical industry, should be taken the control by the government and monitor whether the systems are performing as per the standards or as per the quality. Because again, I tell you, this is a life-saving medicine they produce. So we need to really take a
just add into that, sir. Actually, your wish is correct, and but in the current today's world, when we talk about the life-saving drugs or the life-saving facility, we have from the sterile manufacturing aspects. Typically, people do the online particle counting or the environmental monitoring systems, wherein they generate the 21 CFR compliance data using the SCADA system. And for that, if you have any intervention because of AHU is getting not working, or any intervention happens, or the particle counting goes up because of the XYZ reason, you have to literally put the comment online. That is called as the online particle counting. Online environmental monitoring system is still there. It's halfway, it's still there, but only thing is, and they have to keep the record. Electronically, they have to keep the record and maintain it so that they can show it to auditor. But not the online. The moment it goes up, he's talking about the similar like the pollution control board, because now the outdoor environmental monitoring, if you see the big boards on the traffic points wherein they measure PM1, PM2.5, his wish is that, correct me if I'm wrong, that similar things we should have in the pharmaceutical industry.
Okay, sir, what you were asking is correct. Now all the pharmaceutical industries, especially injectables, where we are filling the under gradient environment, we should monitor each minute with all these worst case locations, wherever that product is going to open status. We should monitor all the different locations. Is every 1 minute, even for example, the 0.5 micron particles, if get just excursion, machine stops automatically. There is no further process. Like that is already implemented for all the injectable plants. Is implemented, and it is also 21 CFR compliance. We should not make any adjust to the actual values. It will be whatever results we got now, it will be printed. All the machines will be having interlock with this online particle counters. Okay? And now that expectations are going on, not only filling area, whatever the adjusting area is there now, supporting area, that should also, we should monitor continuously at one of the location at least, so that the product quality will be maintained.
Thank you, sir. So thank you very much. I apologize for taking 15 minutes more. So let's close now. I hand it over to Mr. Manivendu.
Thank you, sir. Thank you, Dr. Fernasuse, for expertly moderating this session. And thank you, speakers, for patiently answering all the questions. And you